think. Oh, yeah, that's the sound in the background. Let's see. I'm gonna pause that. Alright, let me double check if we are live. Shoot. Usually have a window. Okay, I'll just do it manually. Okay, looks like we are on. Okay, I'll just do it manually. Okay, looks like we. Alright, so quick stream, I guess, for this evening, night. We'll be looking at least do a very basic introduction to Lingua Franca. I added a link to the description for the documentation page. There's you have to install it and all that. They have pretty good directions on how to do that on the page. You can also, to just get started, you can also just try out they have a repo for a playground that you can clone and then run via VS Code, which is what I'm doing at this point. I think it's easy to just get going with that one. So that will be my recommendation, at least for an initial setup. And also I didn't really have any issues as far as opening the repo and then installing the extension. Once you install the extension, you can now go into the examples and try running the code. So for this one, just go build and run, and there it is here. Let me see if I can. Okay. Oh. So that's what was wrong. I didn't have my headphones on. Okay. That's better. At least for me. I think I still need to work out some audio things. At least the volume. On the actual output, I guess, on the stream when people are watching on YouTube. I think I've received I saw a comment that says that the audio is low. I haven't actually spent time looking into that at this point, but I will. Anyway. Okay, so yeah, just getting familiar with um, Lingua Franca. I think the elevator pitch is that it's actually not really a new programming language in the typical sense. It's more of a, I guess you can say it's more of a runtime. It's a polyglot runtime. And yeah, so by the description here, you'll see it says time sensitive, concurrent, and distributed systems. And I think the key thing that they try to really emphasize is the deterministic properties of the runtime. Um, yeah, so actually, that's interesting. I don't think I was fully aware of this part right here, multi-threaded, um, before, but I mean, that's great. And I think the main, based on the things that I've read about it so far, I think the main thing that they are really targeting are cyber physical systems. Excuse me. And obviously, whenever you have such systems, uh, which include real world physical things that need to be part of some sort of state machine, you definitely want a runtime that gives you some sort of um, guarantees about uh, how things are going to execute, right? Um, so yeah, and it's a reactor based, um, as you can see here, and it's also that's the polyglot aspect of it. You can embed um, several languages into it. Um, I think right now they have support for TypeScript, Rust, yeah, C, C++, Python, Rust, TypeScript. But if I had to guess, I would say that their main target language is probably C and then C++, maybe followed by Rust, and then I will rank Python and TypeScript as being equal. Uh, I think the runtime itself is built in either C or Java. I don't quite remember which it is. Yeah, I think it's Java. Yeah, I think it's Java. And I think they have a version specifically for embedded systems, which is. Oh, maybe not. No, I think this is just a reactor. Oh, no, I think. Yeah, okay, I think this is. Um, hmm, I'm actually not sure anymore. Anyway, yeah, the runtime itself is either written in Java or C, but I think it's. I mean, looking at it right now, I think it's. Yeah, I think it's written in Java. I think this confirms it. Yeah. let's see. Yeah, I think that's pretty much the gist of it. Um, as far as why I'm interested in this, um, in one of my previous videos that I think there was doing for the program refiner series that I'm doing. Let me see if I can quickly show it. Videos will be live. Yeah, in one of these, so this is episode 2 of what is wrong with your YouTube? You kidding me? Anyway, in one of these videos, I talk about what it will be like to have a language, a programming language that I guess was more suited for both um, the reality that as AI, LLMs, or whatever AI models become really good at generating code, programming really won't be about the implementation details themselves, or at least in terms of the amount of human hours that go into actually writing implementation details is going to really significantly be reduced, and instead implementation details will be mostly handled by the AI, while humans are gonna be more play the role of being refiners, annotators, and specifiers of programs, and I go on to, I guess, relate it to Andrzej Kapalti's concept of software 2.0. I don't know, you may have come across it before. Um, um, yeah, it's an interesting idea, and I happen to agree with um, with his observation. Um, and so yeah, basically my well my take is that we need a new sort of a new way of programming applications and all that, and part of it is using a runtime. I guess part of it is I guess a language like Lingua Franca really fits into that, I guess, new paradigm, at least from the idea of having a deterministic runtimes that have some sort of known properties and behaviors. And so if you combine that with WebAssembly, you can you know you can limit the amount of unwanted side effects from code that is generated by AI. Like, you can ensure that certain things happen as expected, and things that you don't want to happen, like you're gonna have more control over the code that is being generated. So yeah, so that's, I mean, even before that, I've been aware of lingua franca for a very long time now. I want to say maybe 2 years. Um, and recently I've become more and more interested in um, taking a much closer look into it. Yeah, so I think today and probably for the rest of the week, I think I'm gonna go through um, maybe not all the manual, but um, you know, go through some of the documentation to just kind of get familiar with the concepts and things. And yeah. Okay, so I think I already showed basically running this. Let's see if we can run the same thing. So, okay, so this is an actual, I'm looking at the example folder. In the example folder, we have Rust. And then in Rust, in the source folder, you have snake and you have counter program. Whereas counter program is just a single file, pretty straightforward and simple thing. Snake is, I think it has a bunch of parts, and I think it probably is a good, or meant to be some sort of example for how you can have different modules or components to form a single lingua franca program. Okay. So for this next game, okay, so it highlights external packages are linked using cargo. Okay. The support library is linked into the generated crate. Must include a physical actions are used to run. Logical actions are used to implement a time loop. Okay. Well, what I don't know is, oh, okay. Yeah, let me just. So Rust programs integrate well with cargo, which is definitely a good thing, right? It means that if you're already familiar with Rust and you want to use this, you know, it sounds like there is a path to uh, basically adopting this into maybe existing code bases, Rust code bases. So I guess um, so this is a support module, meaning this is just some Rust module code like a normal one that will then be included in Lingua Franca. Excuse me. Sounds like that's what this is. Okay. All right. So they do have. So as you can see here, they do have a concept of modules, or imports or whatever, like in many other languages. Okay. So you can call snake. So preamble seems to be. So use snake here is definitely pointing to this here. Um, and then you have the other stuff, the termion and rand. Those are coming from here. Well, what's interesting? Well, okay. I was gonna say why not put this over here, but this is just declaring the dependencies. This is where you actually declare. I mean, this is where you actually. Well, this is where you register the dependencies, and in the preamble is where you actually declare your intention of using those dependencies. So that's what a preamble is. Well, I mean, some of these I'm sure you can, just by looking at the code, we can figure some stuff out. So I'm sure there's some documentation where they explain what preamble is. But just by looking at this, that's my guess. Plus, I'm not completely new to Lingua Franca. So some of this stuff is at least vaguely familiar. Um, but yeah, that's what preamble is for. Uh, we'll find out if I'm wrong. uh, and if I recall right, these are parameters. You can think of them as initialization or constants, basically, for the reactor component, like at initialization time. And I mean, they also have defaults, right? Um, these defaults can be overridden by the caller of the reactor. But yeah, these are, I think they call them parameters. And yeah, they're basically configurations for the component. And you can instantiate another reactor inside. So that's good, right? You are creating an instance of another reactor. That's the composition piece. Okay. So, okay. It would be nice if I mean, I would guess that they don't really have an LSP for this yet. Um, but I mean, yeah. Because I mean, this is Rust code, but just I can hover over it to see some information about the circular snake struct. I'm just gonna have to assume that it's coming from somewhere and that it exists and it's like if you don't really have much information about the types and whatever, which is not the end of the world. It's fine for a language that's very much in its, I would say it's still in its research, mostly research phase. So can't really blame them for not having an LSP at this point. Okay, so you have your state variables, and then we have stuff like logical, which I don't think I fully understand yet, so we'll have to look at the documentation for that. Okay, so yeah, more state variables. Which can be initialized, by the way. Missed mentioning that. And some can be initialized based on others as well. And a lot of these, like this direction enum and the snake grid struct, that's actually coming from the snake.rx file. Wait, is my Rust thing even work? Wait, really? I don't have Rust installed. Oh no, I do have Rust. See. Huh. I am not getting anything. Maybe that's not Lingua Franca's fault. My ID is just broken. The Rust language doesn't seem to be working right now. Oh, I think that's the issue, isn't it? For some reason, I didn't have Rust Analyzer installed. So maybe I need to now restart. Except, for some reason, I guess it's not important here, but I've noticed a thing where, for some reason, sometimes when I try to restart cursor, it just won't. Like it just stops, and I have to basically try to turn it back on multiple times before it actually works. It's weird. I don't know if that made any difference, by the way, that we started adding the Rust Analyzer component. I mean, I don't know. I was about to say I can live without the LSP, but I don't think that's strictly true. It's nice to just be able to like, it's useful. It's nice. Is it can can you go without it? I mean, yeah, probably. It's not an absolute requirement. It's just nice, and It's weird to me that it's not working right now. Excuse me. So my takeaway right now is that maybe this example is a little too hardcore for a very uh, for an introduction. Let's see if this keyboard. Yeah, physical action. That seems like a lot to process. Okay, so for comments, you need three things. Oh, okay. So there goes the preamble stuff again. Excuse me. Yes, it is spawn physical thread. Where does the link come from? I guess that's just part of the runtime thing. Do some scheduling. Request stop. ASAP. Again, it's hard to know if this is just a built-in things or it's being brought in by some module. Like, is this a special special symbol of the runtime itself? It's not very clear right now, but my guess is yes. Okay, let's maybe take a step back and look at the actual manual for a little bit. Yeah, I'm gonna put on some sounds. Oh, okay. Let's see if we can actually read this out loud. Excuse me. Okay. A minimal example. A minimal but complete Lingua Franca file where one reactor is this. So we have a target declaration, so Rust, that specifies the language in which reactions are written. This is also the language of programs generated by the Lingua Franca code generator. Every LF program also has a main or federated, depending on the target support, reactor, which is the top level of hierarchy of contained and interconnected reactors. The above sample example has no contained reactors. Okay, it's freestanding, so to speak. The main reactor above has a single reaction, which is triggered by the startup trigger. This trigger causes the reaction to execute at the start of the program. Makes sense. The body of the reaction delimited by these here, the brackets with the equal signs. So it's within that you put the target languages expressions. As we will see, as to a number of functions variables specific to okay, yeah. So I guess this goes back to the comment that I just made few like a minute or so ago, where I was wondering, what's the deal with these? And I mean, yeah, it looks like these are things that are built in to the runtime or the language. Okay, examples of Lingua Franca programs can be found in the Lingua Franca playground. Yep, that's what we have open, right? And if you remember, the way to run that is to just use the repo. Well, no, this is not the actual. Okay, never mind. It's this one, the playground. This is what you want to get started. Okay. So we have the examples. They have regression tests. Anyway, structure of an LF program. The Lingua Franca tools assume that LF programs are put into a file with an LF extension that is stored somewhere within a directory called source. To compile and run the above example, choose the project root directory. Create a source directory within that and put the above code in a file called, say, hello world. You can compile the code on the command line or within Visual Studio Code. Yep, that except I think I've already looked into it. I mean, I've already tried. I don't have LFC installed, which I mean is fine. I think I have installed on my other main account on this computer. I don't really care about installing that right now. I think just using the playground is fine at this point for me. They do have installations for the actual binary. So once you run it, after this completes, 2 additional directories have been created within the project root, bin, and source gen. The bin directory has an executable file called hello world. Executing the file will result, not surprisingly, in printing hello world. The generated source files will be in a subdirectory called hello world within source gen. So let's see. So for the counter program, we have it here in bin, and then source gen, we get the actual code that is generated by Lingua Franca. Hmm. Yeah. Oh, this is generated. Okay. Okay, let's see the reactor block. Reactor is a software component that reacts to input events, timer events, and external events. It has private state variables that are not visible to any other reactor. Its reactions can consist of altering its own state, sending messages to other reactors, or affecting the environment through some kind of actuation or side effect. The general structure of a reactor definition is as follows. Input, output, state, makes sense, timer. And again, this would be the same as, I guess, having a set interval on the window, I think, or set timer. Logical and physical action. Interesting. And then having the distinction between both two. The fact that they're making a distinction is, interesting, to say the least. Okay. Contents within square brackets are optional. Contents within contents within the turbofish, I guess you can call them, are user defined, and each line may appear 0 more times, as explained in the next pages. So okay, so you can have multiple timers, you can have multiple states. Yeah, okay. Yeah. Parameters. Okay, so yeah. Parameters about there. Parameters, inputs, outputs, timers, action, all have names, and the names are required to be distinct from one another. I do wonder if that's only internal to the reactor itself or across all the reactors. My bet will be that it's the former, just because that's just what makes the most sense. If the reactor keyword is preceded by main or federated, then this reactor will be instantiated and run by the generated code. Any number of reactors may be defined in one file, and a main or federated reactor need not be given a name. But if it's given a name, then the name must match a file name. Okay. So your main reactor can actually have a name or not, but if it does, it just needs to match the file name. Okay. Reactors may extend other reactors. Oof. I wish they didn't do that. Or at least, I guess, I hope that the inheritance is only one level deep. Right? My hope is that that's what this is. Yeah, you don't have multiple chains of inheritance involved. Hmm. Okay. All right. And a file may import reactors from other files. If an imported LF file contains a main of an reactor is in yard. Oh, okay. It would just okay. So it's not the whole file that will be ignored. It's just the main of federated reactor that gets ignored. Okay. The Lingua Franca files can have C, C++, Java style comments, and or Python style comments. Okay, input outputs. Do, 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 do. Wait, let's see. Can we find a simple example where they show us the input output? Let me see if I can find something. Void. Oh yeah. Well, okay. Yeah. I mean, it's basically the any type in TypeScript, if I remember correctly. And I mean, so far, I think it's fair to say that it does appear that you can use the target language to its full potential instead of having a very muted version, I think. Of course, C++ is a pretty big language and it would be a little unreasonable to expect Lingua Franca to perfectly incorporate the whole of C++. But I think overall the premise is that you should be able to use most code / expressions, whatever, that you will use in a normal C++ program, that you'll be able to do it here. Because I mean, you can import You can include libraries, external libraries, and everything. So anyway, out, 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 out. Alright, input output declaration. For example, the following reactor doubles its input and sends the result to the output. Notice how the input value is accessed and how the output value is set. This is done differently for each target language. I see. Okay. Setting an output within a reaction will trigger downstream reactions at the same logical time that the reaction is invoked, or more precisely, at the same tag. Guessing the tag thing is some sort of epoch thing. If a particular output port is set more than once at any tag, the last set value will be the one that downstream reaction C. Since the order in which reactions of a reactor are invoked at a logical time is deterministic, and whether inputs are present depends only on the timestamps. The final value set for an output will also be deterministic. So something to really note here is the ordering of reactions as mentioned. So I guess going with something that has multiple ones. This order here is assumed to be the order of execution at runtime. Now, in this particular case, if I'm not mistaken, we don't really have to worry much about how I was gonna say how one affects the other, but that's not true because this one here, this reactor actually, when it makes a change, it actually triggers this. Okay. The type of port is a type in the target language plus the special time. A type may also be specified using a code block. Delimited by the same delimiters that separate target language code from lingua franca code. Any target language type designator can be given within these delimiters. The reaction declaration above indicates that above, they mean here, The reaction declaration above indicates that an input event on port X is a trigger to an output event on port Y. Alright. A reaction can declare more than one trigger or effect by just listing them, separated by commas. So this one here, so you have X and Y. Some. This one says if a reaction fails to test for the presence of an input and reads its value anyway, then the result will get its target dependent. So this is basically saying that it's not absolutely true that that it cannot be possible to have a reaction that is triggered to run somehow. Without having the right set of, I guess, reaction triggers. And this is, well, there's a thing that is to be fixed, I think. A reaction can declare more than one trigger effect by just listing them. Okay, I already read this. Setting an output multiple times. If one or more reactions set an output multiple times at the same tag, then only the last value will be seen. So you can test a reaction, can figure out if it's been changed or not. If a, I guess, is it a state? Yeah, an input. Well, an input to the reaction. Mutable inputs. Normally a reaction does not modify the value of an input. An input is said to be immutable. The degree to which this is enforced varies by target language. Most of the target language make it rather difficult to enforce, so the programmer needs to avoid modifying the input. Modifying an input value may lead to non-deterministic results. Okay? Well, at least they're being transparent about that, which, you know, it makes sense if you're gonna that is the way the reactor objects are set up. It really doesn't make sense to update the input. I mean, even just in general, like, you usually don't want to mutate the inputs that are passed to you, unless you're being passed, you know, actual mutable arguments. Yeah. Occasionally, it's useful to modify an input. For example, the input may be a large data structure, and a redaction may wish to make a small modification and forward the result to an output. To accomplish this, the programmer should declare the input mutable as follows. Okay. So they have a special treatment thing. This is a directive to the code generator indicating that reactions that read this input may also modify the value of this input. The code generator will attempt to optimize the scheduling to avoid copying the input value, but this may not be possible, in which case it will automatically install a copy operation, making it safe to modify the input. Hmm. Okay. Input outputs. And I think I'm gonna stop here because I'm definitely starting to feel like I'm fading away. So I guess tomorrow we'll pick up where we left off today. So next one will be to look at parameters and state variables. Just another programming language that I think it will be interesting to look at is called Hilo. And I think the main thing is that they really are interested in value semantics. Oh, I didn't know that R was really a value semantics thing. Okay. Anyway, yeah, this is an interesting language to think about. Blah, 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 blah. Total domination. This is VS Code. I don't. Okay. So they already have a VS Code thing. They want to take inspiration from Elm and Rust as far as the compiler thing goes. Well, at least the error reporting part. I don't know that they want to emulate Rust's compilation times that people complain about. The last talk they heard was in 2024, late 2024. Excuse me. Subscripts. A subscript is a result pieceware that yields the value of an object or part thereof. It operates very similarly to a function, but rather than returning a value to its caller, it temporarily yields control to the caller to access the yielded value. And it's not just a function. Okay. The program above declares a subscript name min, accepts two integers, and yields the value of the smallest. A subscript is called using its name followed by its argument and closing square bracket, unlike functions which use parentheses. Note that because min does not return a value. Wait, what do you mean it doesn't return a value? Yeah, I'm stuck on this part. Does not return a value. Temporarily yields control to the caller to access the, but when does the control stops? When does it return or take control back from the caller? Okay, to better understand, let us instrument the subscript to observe its behavior. Gosh, I like how I got sucked into this when I thought I was gonna end the stream. Okay, let's actually try to go through this page. Okay, there's no return. To better, let's instrument the subscript to observe its behavior. Similarly to functions, note that if the body of a subscript involves multiple statements, yielded values must be indicated with a yield statement. Further, a subscript must have exactly one yield statement on every possible execution path. Interesting. So yields are basically all potential. I mean, you need a yield for all. Well, yields are exit points, essentially. And does it return state between different yields? In the program above, min has been changed so that it prints a message before and after yielding a value. In main, the first message appears after min. In main, the first message appears after min is called when the project starts. The second appears when the projection ends. Okay. Member subscripts. I'm still a little cagey on this one. This whole subscript thing. Member subscripts. Subscripts declared in type declarations and extensions are called member subscripts. Just like methods, they receive an implicit receiver parameter. Your functions and methods over there, in the documentation for more details on those. Anyway. So these are decorations. Sorry, my mind is simultaneously escaping, thinking about some stuff, and also slowing down significantly because it's past 10 p.m. Okay. Wait, but aren't you supposed to label subscripts? Oh, okay, you put it in front of the thing. Oh, but this doesn't actually have it. It just has the. It just looks like a method with the subscript's name. Okay. No. Never mind. Subscript bundles. Just like methods, subscripts, remember subscripts can bundle multiple implementations to represent different variants of the same functionality depending on the context in which the subscripts is being used. Okay. In and out. This seems like an example where you can have a. Never mind. Immutable subscript can always be used immutably as well. However, in the example above, because the parameters are in and out, arguments to remain in and out will have to be passed in out even when subscript is used immutably. To solve that problem, we can mark the parameters yielded instead, which act as a placeholder for either let, in, out, and sync, depending on the way the subscript is being used. Okay. I definitely need to revisit this. I don't think I'm in the right state of mind to actually really engage with this with full mental presence. I would also love to read more about the scheduler here. I mean, the concurrency thing. There were no function coloring, no different abstractions for expressing concurrency. Alright. Use of abstractions as building blocks, ability to use recursive decomposition, ability to use local reasoning, soundness and completeness. Alright. Yeah, I'm really gonna call it this time because I am slowly fading. Yeah, I hope this was, if this was useful in any way, great. Um, we'll be back tomorrow for more Lingua Franca. And yeah, have a good night.